Here's a solution for the first question in the week 3 quiz. So the question is here. We're presented with a scatter plot and asked a few questions about it. So I think the first thing you needed to do was to sort of understand what was actually being presented in this graph. So the y-axis is actually shown here and the x-axis here. That seemed to confuse a few people, and it's understandable because it's a somewhat unusual presentation. But these numbers along the bottom here are the scale for the x-axis. So oftentimes you would see those actually up here next to the x-axis. And similarly, these numbers down here are the scale for the y-axis. So oftentimes you'd see them here. The scatter plot is just a series of observations. An item for the population was selected, and then its x value, say here about 0.07, was measured, and its y value was also measured here, maybe about 0.04, let's say. And we've got a whole series of those observations. Now, that's probably getting a little ahead of ourselves because the first question just simply asks us to identify which of these two variables, x and y, is the dependent variable and which is the explanatory variable. Well, conventionally, the variable that's measured along the horizontal axis is the explanatory variable, so that would be x down here. And the variable which is explained by x, or dependent on x, is shown on the y-axis. So in this case it's the risk premium for Microsoft. The next question asks us to estimate the correlation coefficient between these two variables. And so a correlation coefficient is measuring the extent of the linear relationship between the two variables, so how close to a straight line the scatter plot is. The correlation coefficient probably has two pieces of information. One is its sign, whether it's positive or negative, and then the other is its magnitude. And its magnitude has to range between -1 and 1. So if we look at this relationship here, it seems there's a general trend that as x values get bigger, so moving in this direction, y values are also tending to get bigger. So that means that there's a positive correlation between these two variables. So getting back down to our answer here, you would have got half a mark just for identifying that there was a positive correlation coefficient. Now working out the magnitude is a bit more difficult, but hopefully as you see more examples of these you'll get a better feel for how a particular kind of pattern of observations translates into an actual correlation coefficient. This one here, if it was a perfect positive relationship, we would see every single observation on this line. That's clearly not the case. And then it would have a correlation coefficient of 1, positive 1. If there was absolutely no relationship between these variables and we just had a sea of observations evenly scattered throughout this diagram, then we'd see a correlation of coefficient of 0. Here it seems to be roughly halfway between those two, so I might have estimated that this correlation coefficient was 0.5. In fact, when I throw it into Excel, I get a more precise answer of 0.58. But for the purpose of this exercise, anything that was in the range of about 0.4 to 0.6 I gave people marks for, but it had to be positive. The final part to the question is a little bit more involved, and we're now asked to estimate the equation of the regression line. Now the regression line here is actually just presented for you. We didn't even have to know that it related to the scatter plot. The line's there and we just want to know what its equation is. So the conventional or standard form of a line is y equals a plus bx, dependent variable y, independent or explanatory variable x. This is the y-intercept and this is the slope of the line. this y-intercept represents y when x is equal to 0, and the slope represents the change in y when x changes by 1 unit. And these interpretations will be important as we start to look at linear regression lines in the next few weeks. When we estimate the equation of the line, we want to have some sense of what the coefficients a and b actually mean. Now, looking at this graph, we can find the y-intercept pretty easily, remembering that this is the y-axis. Now, where does the line cut it? It's about there, which is somewhere between 0.01 and 0.02. So remember, the y-scale is over here, and we're looking at a value down here somewhere between 0 and 0.1, but much closer to 0. So let's just say it's 0.01. So we'll say that this y-intercept is 0.01, and then the final step then is to work out what the slope is, b. Now, to do that, we could choose any 2 points on the line, and that would enable us to calculate the slope. But it is generally better to choose points that are further away, particularly when you're estimating like this, because you'll tend to get a more accurate slope in doing so. So I'm going to choose this point, and this point has an x-coordinate of 0.15 and a y-coordinate of roughly 0.2. I'm going to call that point 0.1 and say that this is x1 and y1 in terms of its coordinates. And I'll also choose this point back at this end of the graph. Now this one has an x value of 0.2 down here, and a y value of, I'll say, negative 0.24, roughly. I'll call this 0.2 and refer to this coordinate as x2 and this coordinate as y2. Now, slope, I mentioned down here, is the change in y when x changes by 1 unit. And one way that we can calculate that is to look at, well, you would have seen the rise over run. The rise in a graph is equivalent to the change in y values. The run is equivalent to the change in x values. So this is often formalized as the rise being y2 minus y1 over x2 minus x1. That was our first point. That was our second point. Let's feed them into this equation now. So I had y2 being negative 0.24. Take y1, my y1 was 0.2. My x2 was negative 0.2, and my x1 was 0.15. Just simplifying that, it's equal to negative 0.44 divided by negative 0.35. I don't know exactly what that is, but it's roughly 1.2 or 1.3. And seeing as we're only estimating, I'm not too fussed which of those it is. So that will then give us our answer. The answer is y is equal to 0.01. I'll change that to approximately 0.01 positive slope of, let's say, 1.3 times x. Done.